Hi, everybody. My name is Kirupa. I'm a product manager at Firebase on Google. And in this vein of today's talk, which is really about scaling products, I'd like to talk to you about reaching 1 billion users with Firebase. And so, if you don't know what Firebase is, it is Google's app development platform. Many developers, small, large, medium sized, tend to build a variety of apps using Firebase. We have about 3 million in market apps over the past 28 days. Some of the names you might see here are probably very familiar to you. They span games, they span mobile apps, web apps, the whole range of applications you might think. Firebase plays a pretty critical role. And the type of apps you might see fall into phone, desktops, laptops, also larger screen devices like TVs or really small screens like your phones and new emerging technologies like augmented reality, mixed reality, virtual reality. All these areas that you might be building your apps in, Firebase plays a pretty crucial role in helping make development possible because our mission is this. We want to help developers succeed by making it easy to build and operate apps. And we really want to overemphasize the word easy because many of you have 1 billion things you're doing as part of running your startups, running your businesses. And app development should be one that is as least complicated as possible for you. And so if we take a step back and look at the architecture, how a typical app is built, there's a part that runs on your device, on your phone, your tablet, or any of the other form factors looked at that you interact with and see. And then the capabilities of your app oftentimes rely on a server, something running remotely. You might have something like authentication, or you might have some complicated activity that requires a lot of computation that you don't want to do locally. So you delegate that to some machine somewhere else. And so Firebase plays a pretty crucial role across all stages of your application, whether it's running on the local device or whether it's relying on something running remotely on a computer hundreds of thousands of miles away. But for today, I want to focus on this part. I want to focus on the server side because it's often an underappreciated part of what it takes to scale an application that gets a lot of users very, very quickly. Now, when we think about servers, we've had them for a very long time. This whole idea of a remote computer on the internet doing something on our behalf or on our app's behalf, it's been around for a very, very long time. For example, here's an example of an early server or server setup from almost 70 years ago, where you have machines that are doing some computation and you have the consumption of it being somewhere else. We're not quite there today. Today we've gone much further. We have more specialized activities that rely on servers on a regular basis. And here are a handful of examples. If you browse the internet, if you use the web to go from page to page, a web server is playing a role. Or if you send an email, there's an email server or an app server. If you're storing any data, like let's say you take a photo on your phone and then that photo is synced somewhere for everyone to access, there's a storage device and really massive computational storage bucket that handles all the data. Or you have databases, or if you're logging in, authentication, all these things rely on servers in some form or fashion. Now, when we think about servers, there are really two approaches that we typically work in. One is managed servers, and this is where we handle all things related to it. And then there's a world of serverless, where we don't worry about servers at all, but we just write code and then everything gets taken care of for us. I want to briefly talk about both of these areas because many of you might be in one of these two buckets, and it's worth looking into where the pros and cons are. So when we talk about managed servers, it's really this. This is the more traditional view of servers. It's the most popular way that all of your application tends to communicate with a backend service. And you basically pay a server provider a monthly fee, and you get access to your very own computer with your own name on it that runs 24/7, and we're responsible for its entire operation. And when we think of a managed server, you might think of visuals of really complicated labs with a lot of wires and very complicated activities that a human being has to perform to keep everything up and running. That is true. There's a part of it there, but luckily we've gotten to the point where everything is pretty much nicely abstracted away. So you can essentially, if you want a server, you get to specify how it's going to look, what capabilities it's going to have, and what kind of software it's going to be running on top of it. And then the way you manage it is not by walking over to a data center, but by having a nice dashboard where you can point and click and configure the various things your server does. But because the server is your own, you do have the ability to almost virtually connect a keyboard to the physical device and own all aspects of it. You have a terminal, you have full access to everything that is going on in your server. So you do have that capability as well. Now, when it comes to managed servers, though, there are some rough edges, some things that if we had to start over today, we may do differently in how we build them. The first one is pricing. With a managed server, you pay a flat fee, and this covers time that your server is actually doing things, but it also covers this probably a long period of time where it's not always doing things. If you look at a typical usage of a server, there's going to be spikes in activity. There will be times when people are waking up, they're using your app a lot, or when they're about to call it a day, they're using your app a lot. But there's a large period of time where there isn't a whole lot of activity going on. But as with how pricing works, you're going to be paying for times that are really not worth paying for because your server isn't doing anything. The second one is scalability, because your server has a fixed amount of resources. You kind of specify up front how much hard drive space, how much memory, how many CPUs is going to be involved. So if your server gets a lot of requests, the first handful that are within capacity will work. But then if you have users who are using it that go beyond what the server can handle, you'll get a very pleasant message. The server will suddenly tell you that, sorry, it can't really help out. You might have seen this error directly, a 429 error where it says a server is telling you that, please try again, or your application might interpret this and give you a nice message instead. And the other part of managed servers is that they're often single region. Your audience might be worldwide, but your server might geographically be in a single location. And typically, the closer you are to the server, the faster your access will be. So in this case, users who are very close to where your server is will have a much better user experience when compared to users who are geographically really far away. They will just have some difficulties. And of course, when we talk about managed servers, the key word is manage. We're managing it. We're making sure everything works, and if something doesn't work, it falls on us to allocate some time and fix it. Here's an example of me running into an issue where I caused a database outage, and basically it falls on me as well to go through and make sure that this gets fixed. So, not exactly the best use of time, especially if you have other things to do. Now, to contrast this world where we take care of the servers, you have the world of serverless, where we don't really worry about servers at all. Now, the word serverless is a kind of an odd choice because it doesn't mean there's no server involved. There's still a physical server, and there's still all the work involved that needs to take place. But the difference is that it's not you or I is going to be dealing with that. We bypass this whole set of activities around provisioning and configuring servers and jump straight to working on application, writing code, enabling service, the things that are really the ones what we want to focus on because we have many things that we need to do. There are a bunch of serverless providers that you might be familiar with. Google Cloud is a very popular one. You have Azure, you have AWS, you have Cloudflare, and of course, Firebase, and which is one we're going to talk about more later. But the idea behind serverless is that you spend more time doing this. You spend more time building your app, writing your code, doing the things that you really want to do. And then deployment is also handled automatically for you. You just say, I'm done with my code, do it, and ship it. And then the capabilities behind the scenes takes care of all the complexities typically involved with getting something to work in your browser, giving an API, and so on. And so let's talk about the various aspects of serverless and how that might benefit us as we're thinking about scaling. So let's start with pricing. Because computing resources in a serverless world, they're brought online on an as-needed basis. There's no dedicated server running 24/7 that needs to be there. So we typically pay for usage, not necessarily just time a server has been going. So earlier we saw about how we were paying for a day's worth of usage, even though the server was only doing work in certain spikes. In the serverless world, the payment is typically on a per user basis. So here you can see an example where I'm paying for exactly the amount of time my server is doing specific work. So it's not really time, but it's more activity. Second, scalability, because a server needs to be available to process requests. In a serverless world, that processing, that provisioning is handled automatically for you. So the number of requests you have determines how many servers are brought online to make this work. And this is all done automatically without us having to do anything. So if you have a very moderate set of requests, you might just see your server handling it really well. But then if you have a lot of requests, the number of servers grows, in accordance with the number of requests automatically. So more servers are brought in, users are happy, no need for you and I to do any kind of configuring. Second part is closer to devices, because serverless doesn't mean that you have a physical server. Your server can be brought online anywhere geographically your users are, which means that just before, when we had a server that was great for people close by, not so great for people further away, in a serverless world, you can bring up a server very quickly in real time to where the close users are, which means that they get a really good user experience, which is always good. So really, if I had to summarize the world of serverless in like a sentence, is really focus on code and services and scale from a handful of users to a billion times that number of users without any extra effort on your end. Serverless takes care of all of that for you. And Firebase plays a critical role here because our entire solution is really based on serverless and simplifying all the various tasks involved here. Not to get into too much detail here, but you can imagine if you have an application with an architecture that requires, let's say in this case, like text recognition, all the various pieces that you need to think about in terms of building your app and making sure the services to handle all this really effectively are handled. Firebase provides you with something that does this really well. And we have a lot of case studies, but I'll talk about my favorite one, which is like, Sworkit, which is really, you have three developers. They have a complicated problem of making a video streaming platform, and it needs to scale as video is pretty CPU intensive. And Firebase gives you all the various things needed, where three developers were able to scale to serve 10 million users by just using the various components and our great documentation needed to make this work. So I'll be wondering, how do we get started? Well, Firebase gives you everything from the easily to the build step, to the deploy step, to the test step for mobile and web apps. So go to firebase.google.com to learn more about how it can help you out. And with that, if you have any questions, I'm always up for discussing any aspect of this. You can email me, you can find me on Twitter, or you can contact me via my blog. Thank you.